Okay, good morning, guys. Today we will be learning about how to solve absolute value equations and how to solve equations involving two absolute values. And you may have to identify special solutions of absolute value equations. Make sure you copy your objectives down and let's get ready to learn. Okay, let's do a little exploration and consider the above or the absolute value equation. Absolute value of x plus 2 equals 3. You may recall that anytime you have an absolute value, the output will be always positive. So the absolute value of 3 is going to be 3, and the absolute value of negative 3 is also going to be 3. It says describe the values of x plus 2 right over here that make the equation true. Use that description to write two linear equations that represents the solutions of the absolute value equation. We just said that the absolute value, in order for this to equal 3, the inside of the absolute value is either 3 or negative 3. Therefore, the two linear equations that represent the solution would be x plus 2 equals 3 or x plus 2 equals negative 3. I'm going to write those here. X plus 2 has to either equal 3 or x plus 2 has to equal negative 3. So that's the only two possibilities. Use these linear equations you wrote in part A right over here to find the solutions of the absolute value equations. Well, if we solve, x is equal 3 minus 2, which is 1, or x is equal negative 3 minus 2, which is negative 5. Therefore, the two solutions would be 1 or negative 5, okay? And then notice negative 5 plus 2 is negative 3. The absolute value of negative 3 equals 3. And if it's 1, 1 plus 2 equals 3, the absolute value of 3 is 3. So that's one way we could use linear equations to solve the absolute value. We would have to set up two linear equations. One equals to the positive value and one equals to the negative value. Because remember, when you put that negative value inside the absolute value, it will become positive. So those are the two ways that you can do that. Let's look at the next exploration. In the exploration number 2, solving an absolute value equation graphically. So if you want to solve graphically, consider the absolute value equation, the absolute value of x plus 2 equals 3, the same one that they gave us before. Well, remember that when they say the absolute value of 3 or the absolute value of negative 3, that's going to be 3. That is because the absolute value of 3, which is over here, and the absolute value of negative 3 is that distance from 0. So notice 1, 2, 3. That's why it's 3 on this side, and it's 1, 2, and 3 on this side. So the absolute value of negative 3 is 3. The absolute value of 3 is 3 because that is the distance they are from 0. So imagine now we could use that knowledge. We could use that knowledge in order to find the absolute value of x plus 2 equals 3. But we would need to make this right here 0. So I want to find the number. It says on a real number line, locate the points for which x plus 2 equals 0. So I want to make this right here 0 because that is the distance. So let's say that. The only number that would make x plus 2 0 is if I subtract 2, it would be negative 2. So x would have to be negative 2. At that point, I'm just going to go to negative 2 and plot that number. Now, this right here would be the distance to that number. And the distance to that number, notice, is if I go 3 to the right and 3 to the left, from there, that's my new 0. That would be negative 5 and 1. So locate the points that are 3 units from the points you found in part A, which we did. What do you notice about these points? Well, these are the solutions. This is what makes the equation true. Because notice negative 5 plus 2 is negative 3, and the absolute value of negative 3 is 3. And 1 plus 2 is 3, and the absolute value of 3 is still 3. So we could use a graph to solve an absolute value equation. That's solving it graphically. Sometimes the graph is not the best because unless you have a huge graph, if you're working with big numbers, then this wouldn't be feasible. If you're working with small numbers, yes, you could use a graph to do that. Okay, so you can use the number line to solve an absolute value equation. Yes, the answer is yes. It is not feasible for big numbers because then you would have to have a graph that is so big, and that wouldn't be feasible for that. But for these type of problems, sure, I would. Now, the next way to solve it is solving an absolute value equation numerically. Consider the same absolute value equation. It says use a spreadsheet as shown to solve the absolute value equation. I went to Desmos, I created my spreadsheet, I put the numbers in. I think I showed you in class how to do that. And now compare the solutions you found. Remember, what the question is, this is right here, this is the output. Look at the output right here. Look at the output right here. Now, what input, which is what you're looking for, what input would give you that solution? Well, the inputs would be what? -5 and 1, which is what we've already found. So you could use a spreadsheet quickly to find solutions to absolute value equations as well. Okay, so you can use that. All right, let's go to example 1 and let me show you how to do it algebraically. Remember, to solve each equation, what we discover is that we need to set up two linear equations. We have an absolute value equations, and we need to set up two linear equations. Those two linear equations have to represent this, what would make this true. Remember, this would be 6 or -6 to be true, right? So I would have to make x minus 4 equals 6, or x minus 4 equals -6. And then I solve those two equations. Add 4 on both sides, so x equals 6 plus 4. X equals 10. In the other one, x equals -6 plus 4. That means x equals -2. When you give an answer, make sure you put it in set notation. So x equals, open a brace, that's -2 or 10. These are the two values that would make this equation true. And you could test it. 10 minus 4 is 6, and -2 minus 4 is -6. Okay, so those are good answers. Please do not start solving here. A lot of students of mine, I noticed that they start x minus 4 plus 4. Do not solve here. Write down two linear equations and then solve those. Do not touch these. This is the answer to that. Okay, so let's go to the next one. It says the absolute value of 3x plus 1 equals -5. Well, notice that this is the absolute value. What absolute value? What can I put inside an absolute value that would yield a negative answer or a negative solution? That the answer is nothing. There is nothing I could put inside the absolute value, because remember, the absolute value of a negative number is positive. The absolute value of a positive number is positive. Since distance is always positive, it will never yield a negative number. So when you see something like this, that the absolute value, it is equal a negative number, the answer to that question, there is no solution. There is no solution to that, okay? All right, let's stop here for a second. Let's go and let you work on these three. Work on these three on your own. Stop the video and then come back and see how you did. All right, let's see how we did. The absolute value of x equals 10. That means x is either 10 or -10, right? Those are the only two values. The first one was pretty simple. The only thing I could put here that would make this true is the absolute value of -10 or the absolute value of 10. Okay? Now let's take a look at the next one. The next one, I have to set up two equations. So x minus 1 equals 4, or x minus 1 equals the opposite of 4. And solve the equation. X is equal 4 plus 1. That means x equals 5, or x equals negative 4 plus 1, or x equals negative 3. So my two possible answers is that x is equal, notice how I give my answer, negative 3 or 5. The next one is pretty simple because the absolute value yields a negative solution, and that is impossible, so therefore the answer to that question is no solution. Pretty simple so far. So let's go to the next one. Notice the next one, solving an absolute value equation. Now, example 2. Do not assume that because you have a negative output over here that there is no solution. Before you can assert that, you have to make sure that the absolute value right here is by itself. In this case, I have a negative 10 next to it, or minus 10. So I need to get rid of that. So the way to do that is you want to add 10 to both sides. So the absolute value of 3x plus 9 equals negative 4 plus 10. That means the absolute value of 3x plus 9 equals 10 minus 4, and 10 minus 4 is 6. Therefore, now I notice it's a positive number, so I am going to have two solutions. So immediately I make my two linear equations, 3x plus 9 equals 6, or 3x plus 9 equals the opposite of 6, which is negative 6, right? So 3x plus 9 equals 6, so 3x equals 6 minus 9. 3x equals negative 3. X equals negative 3 divided by 3, which is negative 1. The next one is 3x equals negative 6 minus 9. Therefore, 3x equals negative 15. X equals negative 15 divided by 3, which is negative 5. So my answer to this absolute value equation would be that x is either equal to negative 5 and negative 1. There are two solutions to it. Okay, so there is your answer. Remember, the absolute value of a number, if it's equal to a positive number, so a number, let's say 1 or more, is greater than or equal to 1, you're going to have two solutions. Or greater than, or actually, I'm sorry, let me rephrase that. It could be less than 1, but it cannot be 0. If it's greater than 0, let's say if it's greater than 0, that means it's a number, a positive number, is going to have two solutions. If the absolute value of x is equal to 0, then it's going to have one solution, because there's only one number, 0. 0 has no positive or negative, so it's one solution. And if the absolute value of x is less than 0, which is a negative number, it will have no solution. So remember that. Okay? That's important. That's for your notes. Okay, here is example 3. In a cheerleading competition, the minimum length of a routine is 4 minutes. The maximum length is 5 minutes. Write an absolute value equation that represents the minimum and maximum length. The first part, solution. Understand the problem. You know that the minimum and maximum length are. You are asked to write an absolute value equation that represents this length. Make a plan. Consider the minimum and maximum length as solutions to an absolute value equation. Use a number line to find a halfway point between the solutions. Then use the halfway point and the distance to each solution to write an absolute value equation. In this case, you could use a number line because we're talking about numbers that are small. If you're looking for the, if you don't want to use the number line, you could use the midpoint formula, which is add the minimum plus the maximum and divide by 2. that will give you the average or midpoint, right? That's the mid, it's also called the midpoint from geometry, remember that? Okay, so once you have that midpoint is what you're going to put inside the absolute value. So it would be x minus that midpoint. And you close it, and then you're looking for the distance to the edge. See, once you have the midpoint, what you're looking for is what is the distance from here, the midpoint, to the end. Either end, because it's going to be the same distance if that is the midpoint. Remember that from geometry, it's going to be the same distance. So what you want is you want to take 5 minus 4.5, and notice it's going to give you what's outside. That distance is what you're going to put out here, that distance. Okay, so the equation then is the absolute value of x minus 4.5 equals 0.5 or 5/10, right? Actually, the way you read this is the absolute value of x minus 4 and 5/10 equals 5/10. All right. So notice that if you put this and you're looking for the answer, notice that 4 minus 4.5 is 0.5, and the absolute value of 0.5 is 0.5. And if you have 4 minus 4.5 is negative 0.5, and the absolute value is 0.5. And if you have 5 minus 4.5 is 0.5, and the absolute value is still 0.5. So that's how you get the two solutions that they're asking you at the beginning. Okay? So let's go to example number 4. Actually, let's go to monitoring your progress. So work on these, see how you do, and then stop the video, and then come back and see how well you did. Okay? Alright, so let me work the first one, number 4. We have that the absolute value of x minus 2 plus 5 equals 9. Remember, you must clear this and leave the absolute value by itself. So the absolute value of x minus 2 equals 9 minus 5, and 9 minus 5 is 4. Now that I have it all clear, I can see that it's a positive number, so there are two solutions. Here, x minus 2 equals 4, or x minus 2 equals the opposite of 4. X is equal 4 plus 2, x equals 6, or x equals negative 4 plus 2. So x equals negative 2. Therefore, the answer is either negative 2 or 6. And you can test that back in the original equation. The next problem is problem number 5. Problem number 5, notice that I have a 4 times the absolute value of 2x plus 7 equals 16. Before I work that, I notice there is a 4 outside of the absolute value on this side of the equation. I need to get rid of it. So do not, again, do not do this. That does not work, so don't do it. If you do that, you're gonna get a wrong answer, so don't do that. Just since you're multiplying 4 times the absolute value of 2x plus 7, just divide by 4 on both sides. Now you have the absolute value of 2x plus 7 equals 4. Once you have your absolute value, notice there's a positive number. You're going to have two solutions. So 2x plus 7 equals 4, or 2x plus 7 equals the opposite of 4. Okay? So we start solving. Minus 7 on both sides. So 2x equals 4 minus 7. Therefore, 2x equals negative 3. X equals negative 3 halves. The next one, 2x plus 7 equals negative 4. So that means 2x equals negative 4 minus 7. 2x equals negative 11, x equals negative 11 halves. Okay, so now that I have my answers here, x is either negative 11 halves or negative 3 halves. That would be the answer, and you can plug that in your original equation and notice that the answer is correct. The last one here, it's a little bit more complicated because it has two steps. It has the step where I have to add 3 and then I have to divide by negative 2. So let me stop this a little bit and make me some room. Okay, continuing on, here we go. So we have negative 2 times the absolute value of 5x minus 1. Subtract 3 to that equals negative 11. So the first thing I want to take care of is this negative 3, so I'm going to add 3 to both sides. So I have negative 2 times the absolute value of 5x minus 1 equals negative 11 plus 3. Okay, so we have that negative 2 absolute value of 5x minus 1 equals negative 8. So now we have to divide by negative 2 on both sides. So I'm going to divide by negative 2 over here. So I have the absolute value of 5x minus 1 equals positive 4. Notice that now that I have that, all I have to do is get the two equations. Remember, once I have the absolute value by itself, now I just create two linear equations. 5x minus 1 equals 4, or 5x minus 1 equals negative 4. 5x equals 4 plus 1, which is 5. X is equal 5 divided by 5, which is 1. 5x equals negative 4 plus 1, which is negative 3. X is equal negative 3 divided by 5. So the two possible answers is x is negative 3/5 or 1. Okay, there you have it. This next problem is a word problem for a poetry contest. The minimum length of a poem is 16 lines. The maximum length is 32 lines. Write an absolute value equation that represents the minimum and maximum length. First, step 1 is I want to find the midpoint or average. Add the minimum and the maximum, then divide by 2. That's how you get the midpoint if you remember back from geometry. So in this case, it's 16 lines plus 32 lines divided by 2, that is 24. This 24 is going to serve me because now I'm going to start writing my absolute value equation. Step 2, you start writing your absolute value equation. Use the midpoint inside of the absolute value and write x minus the midpoint. In this case, it's 24, so x minus 24. Notice it's inside the absolute value, so the absolute value of x minus 24. Step 3, find the difference between the midpoint and either the minimum or the maximum and equal it to the amount. Remember, it has to be positive, so I'm going to take the maximum. So 32 minus the midpoint. 32 is one of the maximum lines that it could be, minus that midpoint that I just found, and I find that the distance is 8. So that is the absolute value of x minus 24 equals 8. That will be your answer. And if you plug in your minimum and your maximum, notice that x represents your minimum and maximum values, okay? And that's how you do it. Take good notes, because remember, hey, if you take good notes, you will do well on that test, okay? The next example is solving equations with two absolute values. When you're solving equations with two absolute values, let's take example A on example 4. So first you take off the absolute value signs and you write two linear equations as well. So the first equation is 3x minus 4 equals x. Notice all I did is eliminate the absolute values. The second equation will be the exact same one, but instead of equals x, equals the opposite of x. So 3x minus 4 equals the opposite of x. Now that you have that, just solve the two equations. I want to move the x's to one side of the equation, so I'm going to move this one to that side. Okay, so then I have negative 4 equals x minus 3x. That means negative 4 is equal negative 2x. The negatives will cancel because they're on both sides of the equation. So now I have that. Flip this. 2x equals 4, right? Just the way you like it. And divide by 2 on both sides. So x is equal to 4 divided by 2. 4 divided by 2 is 2. The next one is I am going to get that 3x to the other side again. Negative 4 equals negative x. I move that to the other side. It becomes negative, so negative 3x. Now I have negative 4 equals negative 4x. Negative 4x equals negative 4. Then divide by negative 4 on both sides. Negative cancel out. So x is equal to 1. So therefore, the only possibilities is x equals 1 or 2. So that's your answer, and you can try them and you see that they actually make the equation true. Okay, the second example on this one is this one right here, B. Again, all you have to do, and let me just make some space here. Okay, again, the first step is to write the equation without the absolute value. I have to write two linear equations. So the first one is 4x minus 10 equals 2 times 3x plus 1. Okay, in this time I just start solving, clearing the parentheses. So it's 4x minus 10 equals 2 times 3x is 6x. 2 times 1 is 2. Then I start moving my numbers, right? I'm going to show you something real quick. Instead of having to add 10 here, I'm just going to move. Remember that when you move the numbers from one side of the equal sign to the other, that they change signs. So if it was negative, it will be positive. If it was positive, it will be negative. So what I want is I want to have the x's on one side, the numbers on the other side. So here is how it goes. I'm going to change the colors of the one that I changed. So this 4x is here. I want this 6x to be on this side of the equation right over here. So I'm going to move it. It's going to become negative 6x. So 4x minus 6x. Okay, that is equal. Notice I have a 2 over here. That minus 10 becomes plus 10 over here. So I'm going to change my color as well, so that you notice that I changed signs. Okay, now I could do the operation. 4x minus 6x is negative 2x equals 12. X is equal to 12 divided by negative 2, which is negative 6. On the other one, I want to do the exact same thing, but the opposite of this right here. Okay, so I have 4x minus 10 is equal to 2 times the opposite of 3x plus 1. Okay, if you would have said negative 2 and just changed this right here, that would have been fine because it would have been the opposite also. But let me do it this way so that you understand where everything is coming from. Okay, so I have 4x minus 10 equals, and let's clear these parentheses first so you distribute this negative 1 to both sides so it's distributed properly. This will become the opposite, so 2 times negative 3x minus 1. So I have 4x minus 10 equals 2 times negative 3x is negative 6x. 2 times negative 1 is negative 2. Now I start moving the numbers like before. So 4x, this is negative, so it will be positive, plus 6x is equal to negative 2. and in this case is plus 10. I start putting together or combining like terms. 4x plus 6x is 10x equals 10 minus 2 is 8. So that means that x is equal 8/10, which you could write it as 8/10 in decimal, or you could simplify this to 4/5. Either way is good. So the two answers possible is x is -6 or 8/10. Okay, and you can test that with your calculator on the original equation and see that it is true. So here you go, work these on your own, and then stop the video and then come back and check. Again, we write the two linear equations, x plus 8 equals 2x plus 1, or x plus 8 equals the opposite of 2x plus 1. So we solve the equation, x minus 2x equals -8 plus 1. So that means -x equals -7. The negatives cancel each other, so x equals 7. The other one is x plus 8 is equal, the opposite of 2x is -2x. The opposite of 1 is -1. So x, notice it's negative, so it will be positive on this side, plus 2x equals, this is positive, so on the other side it will be negative. So I have 3x equals -9. X equals -9 divided by 3 will be negative. So my possible answers is x equals -3 or 7. So that's for that one. The next one, I have 3 times x minus 4 equals 2x plus 5, or 3 times x minus 4 equals the opposite of 2x plus 5. All right, so 3x minus 12 equals 2x plus 5. So I have 3x minus 2x. Notice it was positive, now it's negative. This is negative, it's going to be positive. 12 plus 5. This is 3x minus 2x is x. 12 plus 5 is 17. Next one, 3x minus 12 equals the opposite of 2x is negative 2x minus 5. Notice I changed both negative and negative, okay? So now I start switching. 3x plus 2x equals 12 minus 5. I have that 3x plus 2x is 5x equals 12 minus 5, which is 7. X is 7 divided by 5. Alright, so my answer, x is equal 7/5 or 17. And there you have it. So check your answers, make sure they are correct. If you did well, congratulations. If not, try to correct what it is that you did wrong. Do it again. Okay, sometimes we have extraneous solutions. When you solve an absolute value equation, it is possible for a solution to be extraneous. An extraneous solution is an apparent solution that must be rejected because it does not satisfy the original equation, okay? And that happens sometimes. Here's an example. We have that the absolute value of 2x plus 12 equals 4x, so we do the usual. We create the two linear equations, 2x plus 12 equals 4x, or 2x plus 12 equals the opposite of 4x. We solve the equation, so I want to move this to the other side. So it becomes negative, so I have 12 equals 4x minus 2x. 12 equals 4x minus 2x is 2x divided by 2. Let's switch it so that you see it the way you like. Divided by 2 on both sides, so x is 12 divided by 2, which is 6. Okay, so now that I have one solution, I go to the next one, I move it again, and I have 12 is equal negative 4x minus 2x. Notice 12 is equal negative 6x, or negative 6x equals 12. Divide by negative 6 on both sides, I'm going to have negative 2 as my answer. Now, when I plug those in right over here, if I say the absolute value of 2 times negative 2 equal that x, plus 12 equals 4 times, if x is negative 2, negative 2. Notice that 4 times negative 2 is negative 8. Absolute value will not yield a negative. Notice that 2 times negative 2 is negative 4, and negative 4 plus 12 is 8. The absolute value would be 8. 8 is not equal to negative 8. Therefore, this negative 2 is an extraneous solution. So my answer would be x equals 6, where negative 2 is extraneous. And that's how you answer that question, okay? Make sure you always check your answers, Here is another one, solving an equation with two absolute values. Again, we have x plus 5, example 6, x plus 5 equals x plus 11, and the other one is x plus 5 equals the opposite of x plus 11. So x plus 5 equals negative x minus 11. So let's start solving. So I move it, I move the x's to one side, so I have x, well, this x is going to cancel that one. X minus x is 0, so no x's. So if I cancel this, I'm going to get 5 equals 11. Well, 5 is not equal 11, so that means that is no solution for this linear equation. No solution. But that doesn't mean the absolute value doesn't have a solution. Let's check this one. So negative x, so in this case it will be x plus x equals negative 11 plus 5 will be minus 5. So 2x equals negative 11 minus 5, that's negative 16. And then I have divided by 2x is negative 16 divided by 2, which is negative 8. So the answer for this would be x equals negative 8. Notice there's only one solution, okay? There's only one solution. Okay, here are the 4 problems where you're supposed to do on your own and check your answers. So I'm going to work the problems and you check your answers, okay? So the first one, number 10, I have x plus 6 equals 2x, or x plus 6 equals negative 2x. I have 2x, so I move this x, so 6 equals 2x minus x, and it's x. X equals 6. Or we have that, if I move that one, 6 equals negative 2x minus x, that would be negative 3x equals 6 divided by negative 3, so x equals 6 divided by negative 3 would be negative 2. So my answer is negative 2 or 6. Now I'll check that and notice that when I check that, negative 2 times 2 is negative 4. Well, this one right here, that is extraneous solution. So the answer is not that. The answer then will be 6. X equals 6. Let me put it right. X equals 6 negative 2 is extraneous. Okay, the next one, number 11. So I have that 3x minus 2 equals x, or 3x minus 2 equals negative x. Again, I'm going to move in this case my 3x, so negative 2 equals x minus 3x. Negative 2 equals negative 2x. So I divide by negative 2 is going to be a positive number, because negative divided by negative I can cancel this. So 2 divided by 2 is 1, so x equals 1. Alright, I check the next one. 3x minus 2, move the 3x, so negative 2 equals negative x minus 3x. That will make a negative 4x. Negative 2, negative will cancel. Okay, x is equal to divided by 4, or 1/2. Alright, I have to check those answers. Remember, you may have extraneous solution. So if I put the 1 here, I put the 1 here, 3 times 1 is 3, 3 minus 2 is 1, and the absolute value of 1 is 1, and 1 equals 1. So this answer is good. Now I check this one. Let's check. Go, 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 go. Okay, if x is 1/2, this one is 1. So we have 3 times 1/2, or half of 3 is 1.5, right? 1.5. 1.5 minus 2, 1.5 minus 2 is negative 0.5, and the absolute value of that is 0.5, which is 1/2. So that means this gets 1/2, that is 1/2. So the two answers are good. So the equation has as an answer, x is either 1/2 or 1. Alright, let's look at the next one. Let me erase this so that I have space for it. Number 12. We're almost finished here, guys. So 2 plus x equals x minus 8. So we have 2 plus 8 equals x minus x. Oh, the x are going to cancel. You see how they're both positive. So x minus x equals 0. And 0 is not 10. So that's no solution for this equation. Let's look at the next one. 2x plus x. Oh, sorry. Never mind. 2 plus x equals the opposite of x minus 8. So the opposite of x is negative x. The opposite of negative 8 is 8. So there it is. So now I can move stuff. So x plus x is 2x. Right? X plus x. Then 8 minus 2. 8 minus 2 is 6. X equals 6 divided by 2 is 3. So in this one, x equals 3. Check your answer. The last one, let me erase all this. And let's do the last one, number 13. I have that 5x minus 2 equals 5x plus 4. Notice the 5x is positive on both sides immediately. Notice that. So negative 2 is not equal 4. Therefore, there is no solution for that one. So I'm going to go to the next one. 5x minus 2 equals the opposite of 5x plus 4. That means this is equal to negative 5x minus 4. 5x minus 2. So 5x plus 5x equals 2 minus 4. That means 10x equals negative 2. X equals negative 2 divided by 10, or negative 1/10, right? So that's point negative 2/10. Okay. That's it. That's that. Or it could be 1/5, negative 1/5. All right. Be negative 1/5 if you want a new fraction, or decimal negative 2/10. Okay. So there's only one solution, and that is that x equals negative 1/5. There you have it, guys. So now go to work. Let's go to work. Any questions, just come in and I'll see you in class.